Welcome to this video in the Solutions chapter. Today we're going to take a look at how we measure and express concentrations of solutions in chemistry class. Specifically, we are going to focus on molarity. If you haven't ever heard of molarity, we should see a word that is quite familiar to us in chemistry class, and that is the mole. So we are going to revisit that old friend of ours from unit before. If you haven't already done so, make sure you've printed out your companion worksheet, and make sure as this video progresses you take notes as you go. The end of this video is going to be a calculation section which you will need a periodic table and a calculator for. So without any further ado, let's get started. Today's lesson is going to begin with a talk about concentration. And as you guys know, in the chemistry lab we often are dealing with solutions. And to know the concentration of a solution is a pretty important property. Concentration, by definition, is really a measurement which tells us how much solute is actually dissolved in a certain amount of solvent. Now, where have we seen this term concentrated before, or concentration, or from concentrate? Well, if you look here on the right-hand side, we see orange juice. We always see ads that say, this is orange juice that is from concentrate. Now, what does that really mean? Well, it means that they've taken oranges and they have processed them and made a concentrated pulp of orange solute, which is this here. And what they do is they sell it in these tiny little cans, and then what happens is you bring it home and you then dilute that in regular water, and essentially, if you get the concentration right, you have perfect orange juice that was made from concentrate. Wasn't freshly squeezed, but it's the next best thing. So when I talk about getting the concentration right, we mean it's not too sweet and not too watered down. We have two terms to help us understand just how much solute is in a solution. The term concentrated means there's a large amount of solute dissolved in the solvent. And take, for example, maybe, let's say 58 grams of sodium chloride in 1 liter of water. The converse of that is a diluted solution, and that's where we have a small amount of solute dissolved in the solvent. And that would be, let's say, 5.8 grams of salt. This would be considerably less salty than this solution. To give you guys a visual to drive the point home, you can see here on the left-hand side we have a very dilute purple food coloring solution, and we get progressively more concentrated as we work our way to the right, where there are lots of food coloring droplets per unit of solvent, and we can see that all of these are dissolved in water. And the concentrated one is very, very purple, whereas the diluted one is not so much. And here's another example where we can see a concentrated versus dilute solution. And really, what drives that point home is looking at the number of solute particles, in this case the blue, per number of solvent particles. And here we can see the more concentrated solution certainly has more blue particles in it. Because you can't just tell concentration when you are looking at a solution, we use molarity as a numerical indicator of how concentrated our solutions are in the chemistry lab. So molarity is our chemist's way of expressing just how much solute is present. And molarity is determined by doing a calculation. And that calculation is taking the number of moles of solute that are dissolved per liter of solution. So it's, as you can see here in this formula, it's moles per liter. You guys have to know that formula, so make sure you take it down. And what's great about that is, yes, you should memorize it, but it will be present on your New York State reference table on table T. So make sure you find where that is, and in a pinch, you can always go there to remember it. Once you solve for molarity, molarity has a unit of moles per liter. Because really we see moles over liters, and neither of those are the same unit, so they don't cancel. We also can express molarity as big M. So you could say big M equals whatever the molarity of the solution is, or you can say the solution is X number of moles per liter. There is in molarity calculations the opportunity to be that guy, and it comes in the form of the volume piece of the formula. Make sure that you always plug in the volume of the entire solution, not just the solvent volume. One other little cool nugget about molarity is, sometimes you're going to see a flask that's labeled with the molarity of the solution that's in it, and we may see something that says 3M NaCl. And you guys know that means that the molarity of the solution is 3, but the way we actually would pronounce that is, you guessed it, molar. we would say we have a 3 molar sodium chloride solution. So when you want to express the molarity of the solution, you use the term molar, just like those big teeth in the back of your mouth. So now that we have the basics of molarity and we have the formula down, let's solve some molarity problems. This is going to be scaffolded easy to slightly difficult, but I think you guys are going to have no problem doing these. So make sure you grab a calculator, get some loose leaf and a periodic table and a pen, and let's get cracking. So here's your first problem, and you'll find it on your companion worksheet. Let's try and solve this. What's the molarity of a solution that has 2.0 moles of solid sodium chloride dissolved in 4.0 liters of solution? Well, the first move to solve something like this is most certainly to throw the formula together. Molarity equals moles of solute over liters of solution. Now, if we set this up correctly, it's going to look a little bit like this. Molarity is equal to 2.00 moles over 4.0 liters. And if we do the math, you guys can clearly see that we get an answer of 0.50 moles per liter, or a 0.50 molar solution. Make sure that you guys have two significant figures on here, because we're always going to take the least number of sig figs in the calculation for multiplication and division, and we see that this only has 2 and this has 3, so our answer has to have 2. Problem number 2. Try this one on your own. What is the molarity of a solution with 3.0 moles dissolved in 250 milliliters of solution? Throwing you a curveball. So before you solve this, make sure you convert milliliters to liters. Pause the video now and give this a shot. Okay. If you guys did this correctly, the first thing you did is calculate how many liters 250 milliliters would be, and that would be 0.2500 liters of solution. Once you have that correctly done, we can set up our math. We know that we have 3 moles of solute over 0.2500 liters of solution. Do some simple math. We need to have 2 significant figures for our answer. If you did it right, we should have gotten 12 moles per liter. Let's do one more that's easy. How many moles of solute were dissolved in 4.50 liters of a 0.250 molar solution? So here now we're solving for moles and we're given molarity in liters. So use the molarity formula here, set this one up, pause the video now and solve it, and then we can check our answer. Okay, if you guys did this one correctly, you should have set it up like this, that it was 0.25 molar. Actually, we should have had another 0 here. 0.250 molar is equal to x over 4.50. And if we do this correctly, we should have 3 sig figs for our answer. We should get 1.13 moles of solute in the solution. So far, I think molarity is pretty easy. Where does it get a little more complicated? Well, right here. We are now going to add grams into the problem. How many grams of sodium hydroxide were dissolved to make 2.0 liter of a 1.00 molar solution of sodium hydroxide? Well, they want to know how many grams this is. And if you look at the molarity formula, clearly there is no mention of grams. So, well, what do we know? We know that moles and grams are related. 1 mole is equal to the molar mass of any one of these compounds, or element for that matter, depending on what we're doing. So this is a 2-step problem. First thing we're going to do is set up and solve for moles of solute, and then we're going to take our T-chart and convert moles to grams. Check it out. If you set this bad boy up correctly and solve for moles, we should wind up getting 2 significant figures. We should get 2 moles of NaOH. We're trying to make a 1 molar solution at 2 liters, so we have to put 2 moles in there in order to do that. Now that's all hunky-dory, but this problem wants us to solve for grams, so we're setting up our T-chart. Moles to grams, same thing we were doing back a couple units. We're going to set it up 2.0 moles of NaOH. Well, we want to go to grams of NaOH. What cancels moles of NaOH? We know it's moles of NaOH. We need to know what the equality is. How many grams of NaOH are there in how many moles? Well, we know that in 1 mole of NaOH, and if we were to go do our molar mass of this and add up all the atomic masses, we're going to get 40 grams. So we know that 1 mole is 40 grams of NaOH. Moles of NaOH cancel, and we do 2.0 times 40, and we should get the number 80. But 80 is only one significant figure, so we have to put the decimal point in here to make both of these numbers significant because we had 2 sig figs in our given. So that is how we calculate molarity when we are throwing grams into there. So anytime there is mention of grams, you're going to have to probably solve for moles first and then go do a T-chart. Or if they gave you and said such and such number of grams were dissolved in solution and they want to know the molarity of that, you would take grams, convert to moles, and then plug it into the molarity formula. I think you guys did a good job on these molarity problems, so let's try 4 more. These are all on your companion worksheet. Make sure when you're working your way through there, you have the right units, you set it up properly, you get the correct molar masses, and you have the right significant figures. So pause the video now, and when you're ready to see the answers, hit pause again. Okay, good job. Here we go. If you did these right, these should be your answers. If you have any questions on anything that we did today or you found something difficult to understand, make sure you bring it to our attention tomorrow at the burning questions segment in the beginning of class. So I want to thank all you guys for tuning in. Hopefully molarity will be no problem for any of you, and we'll see you in class tomorrow. Peace out.
That's all, folks.